This video is brought to you by MathGalaxy.com. This is our fractions program, which covers these topics. And here we'll be looking at reducing fractions with greatest common factor and prime numbers. So first we want to look at prime numbers. What are prime numbers? They're numbers that are only divisible by themselves and 1. And it helps to know these, at least. 2 is the lowest prime number, the only even prime number, because all other even numbers are divisible by 2. If a number isn't prime, it's called composite, meaning that it can be broken into smaller numbers called factors that will multiply back to the number. So you can replace 4 by 2 times 2. Basic rule of math is that you can replace numbers by their equivalent. So 6 is composite because you replace it with 2 times 3. And if you break a number down this way, so you can replace 8 with 2 times 4, and 2 with itself, and 4 with 2 times 2, at each level the numbers can replace the original number. 2 times 4 is 8, 2 times 2 times 2 is 8. And there may be different ways you can break a number down. You can break 24 into 2 times 12, and then 12 into 2 times 6, and 6 into 2 times 3, or 24 into 4 times 6, and break 4 and 6 down, or 24 into 3 times 8. So doing it this way, again, at each level, the numbers should multiply back to the original number. 3 times 8 is 24. 3 times 2 is 6, 6 times 4 is 24, and so on. And some people don't want to write numbers all the way down like this. So some of them, once they get to a prime number, they would circle it and stop there. So they would circle the 2 here, the 2 here, the 2 here, and the 3 here. If you do it that way, only the numbers at the end of the branches will multiply back to the original number. So how do you tell if a number is prime or composite? Well, to be composite, you have to have 2 whole numbers that multiply to equal the number. So one way is to start with lower numbers and see if they divide into it evenly. So if we divide it by 2, 3, 4, 5, 6, we find we don't have 2 whole numbers that multiply to 29 so far. And you don't need to go all the way up to 29, because as this number gets larger, its partner gets smaller. But we've already checked the smaller numbers, and none of those have a partner that's a whole number. So you only need to go up until this number is greater than that one. And the shortcut rule is, again, up until this number squared is greater than that. So 5 squared is 25, which is not high enough. We'd have to go up to 6 squared, which is 36, to make sure we've checked all possibilities. But just because a number looks prime doesn't mean that it is. So 91, we need to go up to 10, because 10 is the first number whose square is greater than 91. And you don't need to check all of the lower ones. You only need to check the lower numbers that are prime. So we start with 2, and since it's not even, we know it can't be 2. Next prime number is 3. And the rule for 3 is, if the sum of the digits is divisible by 3, the number is divisible by 3. So 9 plus 1 is 10, which is not divisible by 3. So 91 is not divisible by 3. The rule for 5 is, if it ends in 0 or 5, it's divisible by 5. So 2, 3, and 5 are good numbers to use, especially with large numbers that you're trying to factor, because they will reduce the number quickly if it is divisible by any of these. Okay, the next prime number we need to check is 7. Okay, and lo and behold, it does divide into 91 evenly, 13 times. So 91 is composite. 7 times 13 is 91. So the moral of the story is that don't go by looks. You do have to check by this process. So why are we interested in prime numbers? Well, that's one way to reduce a fraction. So, for example, reducing 18 24ths. We could factor 18 into 2 times 9 and then into 2 times 3 times 3. 24 into 12, into 2 times 6, and then into 3 2s and a 3. Okay, so you can then group them into two groups. One group, the factors they have in common. So one way to do it is to circle them in pairs. So you could compare that 2 with that 2, and that 3 with that 3. So we have 18 gets its 2 and 3, and 24 gets its 2 and 3. What's left with 18 is a 3, and what's left with 24 are 2 2s. This is still equal to 18. 2 times 3 is 6, times 3 is 18. This is still equal to 24. 2 times 3 is 6, times 4 is 24. Okay, so next you could combine the common factors. 2 times 3 is 6, and what's left is a 3. And again, we have a 6 here, and replace that with a 4. So you could cross these out, and you're left with 3/4 as the reduced answer. That's the same as dividing top and bottom by 6. So the common factors multiplied together are called the greatest common factor. That's what would reduce it in one step. And the factors that are left multiplied together give the reduced answer. You could also have reduced it here by crossing out the 2's, which would be equivalent to dividing top and bottom by 2, and then crossing out the 3's, which would be equivalent to dividing by 3 in the next step here. But the greatest common factor reduces it in one step. If you want more review and practice, you can go to MathGalaxy.com. The program has two modes. One talks you through problems step by step. In the other mode, you only give the final answer. And in final answer mode, when you exit, you get a score, which you can also print. And this little character here tells you how many robots you've earned by doing problems, which you can use in a maze game called the Labyrinth. So this is an example of one of the mazes. So you're guiding a robot trying to collect the treasure and getting out, and trying to get out safely. So another example. Okay, so, and the screen may look a little compressed vertically. And that's because of how the video is being recorded. But in the game, it's a little more square and symmetrical. So another example. So another game that comes with the program is a riddles game that's like Wheel of Fortune, where you can have up to 3 players. For example, here the riddle is, why did the elephant paint herself different colors? So you can choose to, or you can try to solve the riddle at the beginning or end of each turn. So player 1, let's guess a letter. So A is 3/4 plus 3/4, 6/4, which is 1 1/2. So A should go there. And let's pass on to player 2. let's see, E is 1/2 plus 1/8. So 1/2 is 4/8 plus 1/8 is 5/8. So E goes there. So you can continue on trying to guess letters, and if you get to a point where you think you can solve the riddle, it's like here, why did the elephant paint herself different colors? Let's say to hide in the crayons. Okay, so it looks like that worked. And another game is called Bridge the Swamp, where one player, red, is trying to build a bridge in this direction, green is trying to build a bridge in this direction, and the first player to complete their bridge and block the other player wins. So here red goes first. Say that red wants 5, so those two should add up to 5. And let's say green wants to block with 13 1/4. So 5 3/4 looks like it'll give an extra quarter with the half. 5 and 7 are 12. So it looks like it'll work. So those are examples of the games that come with the program. So that's a review of reducing fractions with greatest common factor and prime numbers. And if you want more practice and review, you can go to MathGalaxy.com. Thank you for listening.